Now it seems like it's on. Thank you so much for the introduction. So glad to see you guys today. So today I'm going to talk about basically weed management, especially herbicide usage in turf and landscape systems. I sort of designed this presentation around a lot of the questions that I get regarding herbicide usage in landscape systems, especially with sensitive plants like trees and shrubs in the areas. So today we're going to talk about the good, the bad, and the very, very ugly. So to get started, if you've ever seen one of my presentations before, you have seen this slide, I guarantee you. If I were to say that there was one slide that covers the entirety of everything that is important about being successful as well as sustainable in your weed management practices, this is this slide. So you've probably heard the saying, the early bird catches the worm, right? Well, the universal truth is, regardless of the management that you use, regardless of the tools, if you're kicking at it, if you're hitting it with a stirrup hoe, if you're cursing at it, or if you're hitting it with a herbicide, the most effective method of control is to get the weed when it is young. Notice I said young and not small. We probably know that size is really not an indication of maturity when it comes to weeds. Unfortunately, I forgot to put it in there, but I have a great picture of a pigweed plant that's no bigger than my thumb that has up to 15 leaves and a viable seed head attached to it already. So just because it's small does not mean that it's not outside of the mature level that a herbicide can control it. So what is a young plant not produced yet? Anything. Right? But mostly seeds. You guys are correct. But if you're talking about pulling it out of the ground, what's easier to pull out of the ground? A root that's a couple of inches deep or a root that's 30 feet deep, like dandelion, for instance, right? The deeper it goes, the more likely you're not going to pull out the rest of the root, and then what happens? It grows right back. Even some annuals have this ability. So when you talk about management decisions and how we start to decide what type of management tools that we can use, processes that we can use, there are things that we really have to take into consideration, and that's going to be based on the biology of the weed, right? It's important to know if we're dealing with annuals or perennials, isn't it? Because I guarantee you there's a lot more tools available for this option than there are this one. So what happens if we are dealing with perennials? What are some of the things that we need to consider? Well, we need to consider what are the reasons for that weed's success. Does it produce a lot of seed? Does it have a deep taproot system? Does it have rhizomes, stolons, or both, or tubers? Every time you add a finger, what happens to the difficulty? It gets higher, right? So, the other thing that we have to consider is periods of active growth. So targeting the weeds when they're young is actually relatively simple to do with annual plants, isn't it? Well, simple in the traditional sense of the word. Because we can target them when they're germinating from seed every single year. We can't really do that with perennials. So what's the timing that we aim for? Periods of active growth. And we'll talk about that on the next couple of slides. Identification is the key. Dr. Lujan mentioned that we have the plant diagnostic clinic here. I'm happy to help with any kind of identifications that y'all have. Shoot me an email with some pictures. Shoot me some plant specimens from the plant diagnostic clinic. Identify your weeds first. Then start figuring out what we need to do from the perspective of what management we need to attack it with. And integrated pest management. The utilization of as many tools as possible to keep those weeds confused and injured as much as possible is going to increase your success. Most people think that integrated pest management is management in the absence of herbicides, when in reality it is herbicides as a last resort. Utilizing all the other practices that Dr. Lujan mentioned in his presentation first to see if they have any effect on the weed, and if they don't, save the big guns for the big weeds, right? So like I said, this is a pretty much summarization of all the important things to consider with any kind of weed you're dealing with, regardless of the cropping system, regardless of the management. We talk about integrated pest management or integrated weed management in this case. It's important to understand that there's multiple tools available, there's multiple practices that we can use against weeds, but not one of them is going to be successful by itself in a sustainable way. So even if that management practice is going to actually control the weeds that you're dealing with right then and there, what happens in the interim? Other weeds start to move in, don't they? That don't respond as well to that management practice. We call that a population shift. And when that happens, you have to adjust your management. Otherwise, that's just more time for that population shift weed to start to invade, become more prevalent, and more difficult to control, right? So we have combinations for good management practices utilizing prevention first. How effective is prevention? Pretty effective, isn't it? Especially if you have a plant like, say, pigweed, for instance, that produces 600,000 seed in one season. Or field bindweed, where the seed can survive up to 70 years in the soil. This is where everybody starts to have an existential crisis. That's okay. This is what we need to know in order to be successful, right? Prevention doesn't work, we can utilize mechanical. Most people ask me, what is the most effective method of organic weed control? Anybody know the answer? Your hands. Tools, right? Cultural practices. We're going to talk about cultural practices on not the next slide, but the next. And one very specific cultural practice that I think gets overlooked when we talk about developing a successful weed management strategy. And of course, if all of these don't work, then we can utilize herbicides, but always based on the biology and the timing of the weeds. Sorry, my hands are shaking. Strategies should be specific to the target weed, accurate identification, and targeting it to the biology like we talked about on the first slide. Weed life cycle. Is it important to know if it's an annual, perennial, or maybe even a biennial, or both? To complicate matters any, thanks Mother Nature, right? Winter annuals. If we're trying to get them when they're young, when they're germinating from seed, why is September through November the optimum window of control? What's happening? Temperatures are going down. Maybe in New Mexico they're going down about this way, but they are going down. And as they go down, those cooler temperatures foster the germination of winter annual seeds. Target the weeds when they're young. So knowing that, should I apply a herbicide to a winter annual weed in the spring? The universal extension answer always has to start with, that depends, right? Did it germinate in the spring? Those temperatures are also conducive in the spring to the germination of winter annuals as well. If that's the case, then maybe it is still in that young stage to be controlled by a herbicide. But what if it germinated when it was supposed to in the fall? What's going on in the spring by that point? It's way too mature. It's probably already dropped its seed. You've missed your window of opportunity, and that is a wasted herbicide application. Everybody see that? Summer annuals. Why is May through June the typical timing? What's going on? Temperatures are going up. Those temperatures may be already up in February. We don't know yet in New Mexico, but temperature is really what this is based on. Target the weeds when they're young. What about biennials? How long do they survive? 2 years. Peace, right? 2 years. So we have 2 whole years to control these weeds before they drop seed. Not so fast, right? As long as they're growing in that first year, all it's trying to do is beef up its root system. The deeper the root system gets, the more robust it gets, the more difficult it is to control, the more your management is probably not going to work without repeated usage or applications, right? Then it comes back the following spring and it does something called bolting, meaning it shoots up a stem. So you've probably seen this in, say, London rocket, for instance, or our thistle weeds like musk thistle or bull thistle. Once they start extending that stem or bolting, that is an indication that herbicides are not going to work. They're too mature. So don't spray a herbicide on a bolting plant, basically. Oops. Perennials. Most of the perennials that we deal with are kind of summer, spring, warm season plants, aren't they? Dandelion, Bermuda grass, field bindweed, silverleaf nightshade. So why in the world is fall application the best, or fall management? Think about it in terms of a dandelion. In the fall, it knows that what's coming? Winter, right? Like Game of Thrones. Any fans? Just kidding. Late September through mid-November, it knows that winter's coming, so what's it doing? Is it focusing its growth on leaves or roots? Roots, to survive the winter. So if you make a herbicide application, especially at this time, what's going to happen? It's actively growing, it's going to move in the plant more effectively, and it's going to go where? To the roots. It's going to impact the roots. What do we want to injure the most on a perennial plant? The roots, right? I actually did a research project a couple of years ago in alfalfa looking at just herbicide applications for field bindweed control. Anybody tried to control field bindweed in the audience? Pretty difficult, isn't it? But we actually were looking to compare different herbicides. We weren't really paying that much attention to timing, so we made a fall application of a traditional variety of different herbicides, and guess what? Even with some of the older herbicides that have been available for 40 years, we got almost 100% control the following spring because we applied it in the fall. Timing is that important, right? So why is the second best timing March through May? What's happening? Roots or leaves? Leaves. So if you interfere with that process, if you dig it up, You scrape it away with a hula hoe, or you hit it with a herbicide. It interferes with that leaf growth. It has to do what? Use up its root system in order to grow more leaves. Lather, rinse, repeat until it doesn't grow back, right? So those are the two best opportunities to make an application, especially with herbicides, on a perennial plant. Anything outside of that timing is not going to yield you as much injury, is probably going to be a wasted application, or you're going to have to make multiple applications to do the same thing one could have at the right timing. Diagnosing weed problems. Who can tell me what the weed is in the picture? Who says it's a thistle? Musk thistle specifically. Who says there's about 10 different plants in that picture? Exactly. This is a picture that I did receive, so I had to send an email back saying, which one? Sorry. Sometimes it's worth it to take a step back and take a look at the entire picture before just barging in with a management option. Because what also was very telling to me in this photograph when mentioning management options for this particular weed, it was the thistle, by the way. Can I just recommend any herbicide? Why not? There's trees in the background, very close to those plants, aren't there? Additionally, these plants are on the side of a roadside. So you have concrete and asphalt there that might interfere with the ability of the herbicide to break down and wash it away off-site. We also have a drainage culvert. So there's a lot of different things going on in this picture that really impacted what kind of management I presented to this person as far as helping to control these types of weeds. So sometimes it is worth it to really take a step back, look at the bigger picture, and then select the management option. Why are the weeds there? This is a cultural practice that I was talking about that I don't think is really considered quite enough when it comes to weed management, and that is indicator weeds. The presence of certain plants in certain areas might indicate an environment that is favoring their growth over the growth of your desirable plants, whatever they may be. And that may be something that we can adjust as managers. So if you have a weed that likes very specific conditions, like I'll show you on the next slides, what's the first thing we need to do? Spray it with a herbicide? No, we need to fix this environmental condition. Otherwise, it's going to continue fostering the weed, and you're just going to keep using the same management over and over again, most often to a wasteful result. So a good example of that, can anybody tell me what this weed is? Nut sedge, nut grass, right? I would call it nut sedge. Some people call it nut grass, and it does look like a grass, doesn't it? But it is a sedge. It's a completely different family of plants. You cannot manage sedges the way you do grasses. That's important to understand. But sedges love wet soils. So what's going on in this picture? There's a drainage issue, isn't there? So every time they water this Bermuda grass over here, the water can't drain in these soils. It becomes stagnant. It becomes full of water, no air for the roots, which is what Bermuda grass needs. Therefore, the nut sedge is taking over. So I can spray this to kingdom come, but until I fix this drainage issue, it's going to keep fostering the nut sedge, isn't it, over the Bermuda grass. Another good example, it's probably hard to see what kind of weed this is. This is white clover. Anybody know what white clover does that other plants don't? They fix nitrogen, don't they? So if you have a high concentration of a legume plant that fixes nitrogen over, say, a desirable plant like maybe turf grass in this instance, because we're dealing with a baseball field, what's the first thing I need to do as a manager? Spray it, fertilize, right? Because this soil is deficient in nitrogen, this is getting the competitive edge because it can create its own in a deficient system. So we have to supplement that, don't we? So that's what I mean by indicator weeds. Now, fertilizing with nitrogen is not going to kill the clover, is it? But it'll give competitive edge to whatever desirable plant we might try to be growing in that area if that's what we wanted to do. Not saying, white clover is an automatic weed to control, of course. Can trees and shrubs be weeds? Absolutely. This is everybody's favorite, isn't it? No. I understand. I usually ask my audience, who here likes dandelion? Because dandelion really skirts that gray area between being liked and weedy. Nobody's wrong in this scenario. It's just the subjective nature of the term weed. Salt cedar, on the other hand, pretty much always a weed. And why is that? It's draining our freshwater resources, isn't it? This one tiny little salt cedar plant over here, I say tiny, for a shrub it's tiny, or a tree it's tiny. But that tiny tree can take up to 100 gallons of water out of the soil every single day. That's how it's draining our freshwater resources. Other trees, like Russian olive, do the exact same thing. Takes up just as much water, doesn't necessarily use it all, and just breathes it back out into the atmosphere. That's not something that we can afford to have happen to us in the desert, can we? What about Siberian elm and tree of heaven? How tree of heaven got its name, I don't know. Technically, it's tree of, right? This is actually my favorite photograph of a Siberian elm literally growing out of the crack of a sidewalk in Taos, New Mexico. That's in the center of town, right in front of a really nice shop. So, trees and shrubs can be weeds. How do we manage these trees? Why are they weedy? Well, they usually have an aggressive root system that's difficult for our management to control. So like I said, the combination of as many practices as possible is going to be more effective. With salt cedar, for instance, we have mowing and we have grubbing, meaning that you take a drill and you actually grub out the root system underneath so it can't grow back. Hard to do with Siberian elm, salt cedar, because it has multiple root systems. Can't really pinpoint one, and they can go up to 30 feet deep in the soil. You can also utilize fire. If you're wanting to get out some of that aggression from the work week, get out your flamethrower and just go out there and burn it to death, right? Probably not the best method, but we'll definitely get some of that anxiety out. Well, not anxiety, but anger maybe. Goats do feed on salt cedar. They're probably the cutest aspect of weed control. Anybody know what this guy is? Salt cedar leaf beetles. They are the poster childs for biological control. And then, of course, as a last resort, we also have herbicide applications. So if we use all of these by themselves, what's going to happen? You're going to injure the tree. You're probably not going to kill it. Even with a blast of herbicide that is very effective against salt cedar specifically, you're probably not going to get 100% control with that one application. And why is that? Because of that deep underground root system, it's very hard for those herbicides to kill it, and it's able to actually regrow. But you start to get this sort of stunted leaf growth looking like pipe cleaners or Christmas trees from the 50s, so I hear, right? So we're injuring the tree, of course. But there are timings, there are ways that we can implement, especially herbicide applications with these tree control methods that can be more successful. One of those is through girdling. Now, girdling in itself, just cutting through a portion of the tree, getting through that cambium tissue, through the bark, through the cambium tissue, straight to the heartwood. It's about as far as you need to go, really. So what's going on there? You sever the You sever the cambium tissue. The nutrients and water can't get up from the roots into the leaves. The leaves can't send nutrients down from photosynthesis into the root system. Ultimately, the tree dies. But what's the problem with these weedy trees that I talked about? Above that cut, the tree's probably going to die. What's going to happen below that cut? It's going to sucker, isn't it? So usually those cuts are paired with a very specific, very localized, maybe even painted on with a paintbrush herbicide application. If you were to just go ahead and cut the tree down, all you would need to do is paint that herbicide directly on that cambium tissue in between the bark and the heartwood. What's that going to do? It's going to take the herbicide down into the root system, and it's going to actually injure those roots effectively to hopefully prevent suckering as much as possible. Now, the thing to understand is that you have to make this herbicide application, if that's your chosen method of control, within 10 to 15 minutes after making that cut. What happens if you don't do that? The vascular bundles close. What happens to your herbicide? Nothing. It's a wasted application. So there's another method that's pretty popular called hack and squirt, which is something I still hate saying out loud. I can't call it anything else. And literally just taking a hatchet or an axe, hacking at the bark through the cambium tissue into the heartwood, and literally with the other hand squirting the herbicide in. Now, if you're clumsy like me, that's a good way to lose a leg, but it is an option for control. The thing to realize is that as long as you get that herbicide application in almost immediately, it's going to be an effective method of control. And there is timings that this is going to be more effective. If you're talking about tree of heaven or Siberian elm, you want to do this in the fall, just before those leaves start to change their fall color. That's when the tree is going to be actively growing at the most, and so what's going to happen to your herbicide? More of it's going to make it down into the root system. Speaking of herbicides, This is probably something familiar at your local garden center, isn't it? So my favorite color is green. I can just go get a green bottle and go take care of whatever weed I have, right? Wrong, right? Unfortunately, we can't really look at the color of the bottle. We can't really even look at the big name from the company. That's the trade name. What we have to look at is the tiny little bitty writing here in the lower corner. That's the important thing to look at, the active ingredients, to see if that's going to be effective against your weed. When you talk about herbicides, chemicals, pesticides, would everybody agree that those terms kind of have a stigma attached to them nowadays? The thing to understand about herbicides, pesticides in general, is that anything that you are using to suppress or kill unwanted vegetation is a herbicide. Just like anything that you use to kill a pest is a pesticide. Just like anything you use to kill insects is an insecticide, right? And that absolutely includes our organic options as well. And it's important to think about them as herbicides because spraying a high concentrated acid into the environment surely can't cause any damage, right? We have to make applications safely as well as successfully, and we have to do that with our organics just like our traditionals, right? But there's a lot of different methods of management out there. Herbicides are still the primary method of weed control. The reason being is that they are relatively inexpensive, although that can be debated with organics. If you saw my presentation last year, you'll know exactly what I'm talking about. Greater flexibility and timing of weed control. You can make an application earlier in the spring, and then maybe there's active period for a couple of months to control weeds as they're coming up so you don't have to spray. Results are often quick. I don't know about you guys, but when I spray a weed, I want to see it melt before my eyes. That's actually something that you will get with the organic options because you're essentially burning the surface of the leaf away. So you'll start seeing symptoms within about an hour or so after application. Some of our traditional systemic herbicides like glyphosate, for instance, might take anywhere from 10 to 14 days to cause injury, and we'll talk about why that is at the end of the presentation. The thing to understand about herbicides, just like every other management practice we talked about, is that they are a helpful tool. By themselves, they will not create successful and sustainable weed management. Why is that? You have to keep spraying it. One of the questions that I get asked surprisingly a lot is, what's the one organic herbicide that kills every plant except the ones that I want it to for the end of time? Doesn't exist, or it shouldn't exist if it does. Success is always going to be dependent on accurate identification of the weed and the desirable plant, because you don't want to spray your desirable plants accidentally. Applications in accordance with the label. Read the label, read the label, read the label. Can't stress how important that is. If I could tattoo it on my forehead, I would. My mother might not be happy with me, but it might emphasize just how important that is, and the label supersedes everything I say. All the information you need to make a successful and a safe application is in the label. And consideration of other desirable plants in your area. That's what we're going to be talking about in the rest of the presentation, especially regarding herbicides, because if they're not applied in accordance with the label, off-site damage can occur. And all of the county agents and the other specialists in here have experienced the same as I, that 99.9999999% of the time, if off-site damage or injury occurs, it's because the application was not made in accordance with the directions of the label. So whose fault is it? The applicator's, isn't it? It can occur when active ingredients move off-site through drift, volatilization, or leaching. Drift and volatilization is movement through the air. Drift is those particulates that just don't settle. We'll talk about vapor drift here in a moment through volatilization. Leaching, movement through water, either through the soil or on the surface. So specifically talking about herbicide drift, because when it comes to herbicide damage that I see at the plant diagnostic clinic, I'd say probably 80% of those samples are as a result of herbicide drift, either through the particulates moving in the air through actual drift or through a process called volatilization. That doesn't mean that the herbicides have a temper. It means that they react to temperatures. So you talk about 2,4-D and dicamba being volatile. What happens when you add liquid to a hot temperature? It evaporates, isn't it? If you make applications of herbicides that are volatile, like 2,4-D and dicamba, in hot temperatures above 80 degrees Fahrenheit, they can evaporate as a gas into the air. So the herbicide is actually here as a gas. So what happens when the wind blows? Moves off-site, gets in your neighbor's trees, and that's how you end up on Judge Judy, right? It can also move through herbicide-contaminated soil. Now, there's very specific herbicides that are usually the culprit when we talk about movement through contaminated soil or compost. Those are the long-lasting herbicides like aminopyralid or clopyralid or picloram. So if you're getting hay from a certain area or a grass hay field that had those herbicides applied, it may be that that herbicide can stay active even through the processing of the hay, feeding it to the livestock, moving through their digestive system, and pooping it out, causing manure that you can add to your compost and that composting process. When you add that compost to your vegetables, it can still be active to kill your vegetables. How do you avoid that? Test your soil. If you get compost, either you're purchasing it or you're making it yourself, or especially if you get it from the city, put it in a little pot first. Plant a bean or a pea seed in it. See if it comes up. See if it comes up warped or chlorotic or doesn't come up at all. Doesn't mean it's automatically a herbicide. There may be something else in there that's preventing growth, but the moral of the story is if you have a pea or a bean seed that doesn't respond the way you want it to, maybe don't put that compost in your vegetable garden, right? What can cause drift? Let's see what factors we have that are pretty prevalent in New Mexico. High wind, check. Low relative humidity, check, check. High temperatures, quadruple check. Increased spray heights. When you're trying to rush through making your application, maybe you're not holding the boom at the right height and that wind can get underneath and spread those particulates. How do we avoid drift? Learn the locations of nearby sensitive plants. Be a good neighbor. State Farm is not always there. If you do have sensible plants in the area, maybe leave a buffer zone. Some herbicides require a buffer zone, like some of our soil sterilants, for instance, like Diuron. It'll have a statement in the label that says stay 250 feet, 350 feet away from the nearest tree trunk. What are we trying to avoid with that? Movement to the roots, right? That's called a buffer zone. Avoid the use of volatile formulations if environmental conditions favor movement as a gas or through drift particulates. There are other herbicides to choose from, or don't use a herbicide at all. Better to be safe than sorry. Do not apply herbicides when the wind is blowing towards sensitive plants. Ideal winds are between 2 and 10 miles an hour. Now, why didn't we say 0 miles an hour? Wouldn't that be ideal? Would be, but we actually kind of need a little bit of wind to sort of break up those particulates in the air. Otherwise, they just stay there. And then what happens when the temperatures start to change? You get a temperature inversion, meaning that those clouds of drift actually move higher into the atmosphere and move further away. You've heard of some of the temperature inversion situations in the southeast with some of the low volatility dicamba and 2,4-D products. Some of those drift clouds are moving up to 20 or 30 miles away from where they were applied. So that's why we avoid temperature inversion. Spray when temperatures are below label restrictions, usually below 80°F. No problem for us, right? Use wide-angle nozzles. The larger the droplet, the more likely it is going to make it to the plant that you're targeting instead of staying in the air. Use lower application speeds and pressures. Going faster does not always mean it's going to produce better results. You can even use shielded booms to actually catch some of those drift particulates if you're actually near sensitive plants, like, say, spraying in a chili field, for instance. And, of course, read the label. So what happens if our sensitive plants, like our trees or our shrubs, are exposed to particle drift? They do have herbicide damage attached to them. What can we do? Read the label and don't do it again? So what can we do? Unfortunately, once the herbicide is in the plant, it's in the plant. It's sort of the same concept if I decide to take a bunch of aspirin, decide that's a bad idea, and I cut my arm off to get it out of my body. Doesn't work like that, does it? I really need a new metaphor for that. You can try to prune affected areas that have the herbicide damage if possible. However, in reality, you're just going to have to wait and see if the tree survives the damage and is able to grow out of it. And I've seen some trees that look dead that have actually come back. I have pictures of those at the end of the presentation. But unfortunately, I would actually usually advise against pruning the tree or pruning the area that has the herbicide damage, because that's going to stress the tree more. If you have herbicide damage in your tree, all you can do is water it, fertilize it, try to grow as healthy a tree as possible to grow out of that injury. And please don't put activated charcoal in your soil. It's not going to do anything. Fertilization. There's different options for fertilizers out there, aren't there? There's organic and the synthetic options. Pop quiz time. What does a plant prefer, organic or synthetic nitrogen? Who says organic? Who says synthetic? Who says it doesn't matter? See, you guys are so smart. Doesn't matter, does it? Nitrogen is nitrogen. Just like if I'm deficient in vitamin C, my body doesn't care if I eat oranges or I take supplements, right? But of course, my body's only going to absorb so much. A plant only takes up so much fertilization. So before you ever put a fertilizer to a plant, what's the first thing we do? Well, read the label, absolutely. And test the soil. But one of the questions I get frequently asked is regarding weed and feeds. Anybody seen these at your local garden center? Herbicides in combination with fertilizers. More bang for your buck, right? Wrong. Fertilizers that contain herbicides, they can contain pre-emergent herbicides, they can contain post-emergent herbicides, or both. How do we know which ones? Read the label, right? I usually don't recommend weed and feeds. The reason being is that there's not a whole lot of either one in the bag, first of all, but there's just enough of that herbicide to cause injury if you don't apply it right, in accordance with the label. How often does that happen? A lot of the herbicide damaged trees that I see in the plant diagnostic clinic are from weed and feeds, specifically. The problem is that in many cases, the best time to feed the lawn is not the best time to control weeds. Remember me talking about timing? So we talk about what's going on with the temperatures outside. Has the Bermuda grass come out of dormancy yet? No. But summer annual weeds have already started germinating in some areas, haven't they? So if we're going to get a weed and feed out, we need to get it out. But what's the problem? Bermuda grass is not going to take it up. It's not actively growing. It's still dormant. So the right timing for the weed is not the right timing for the lawn. And vice versa, if we wait until the Bermuda grass does come out of dormancy, what happens to the weeds? They're way too mature. So it really is more bang for your buck to get a herbicide and a fertilizer and apply them both at the appropriate time. Does that make sense? Sorry if you sell weed and feeds. Some of the post options are volatile. Some of the post-emergence options that are very commonly present in these weed and feeds are 2,4-D and dicamba. And so if they're present as a granule attached to a fertilizer, what does that mean for their ability to actually volatilize into the air? They're going to be available longer, aren't they? It's more likely that those temperatures are going to reach that level to cause them to volatilize. What also happens if that herbicide is actually root absorbed, like dicamba is? It actually lasts longer into the soil, and so it's more likely that it's actually going to make it down into the root system if you sprayed it over your tree roots. There's just enough product in that bag to cause injury if you don't apply it correctly, right? And a lot of these bags look alike. How do I know which one is the post-emergence and which one is the pre? Read the label, right? So this one here on the left actually has dicamba, 2,4-D, in the bag. What does that mean for its volatility potential? It's probably pretty high. I guarantee you if you read that label, there's going to be a statement saying don't apply this in temperatures above 80 degrees Fahrenheit. But when is the Bermuda grass going to be growing? Temperatures above 80 degrees Fahrenheit, probably, right? This other one here on the right is prodiamine. Anybody know what prodiamine is? A pre or a post? It's a pre. So you have to apply this completely different than you would this in order for it to be effective against the weeds. So some people think that because they do the same thing, I can take this label and use it to make that application. Can I do that? Absolutely not. Please don't. Please. The other thing about herbicides is their selectivity, knowing what herbicide does what to what plant, which ones to avoid and which ones to target. We have our non-selective herbicides, probably the most famous being glyphosate, but also our organic options as well. Acids and oils don't have the ability to choose from pigweed or your vegetable plants, do they? So, there are selective herbicides. There are herbicides that won't harm grasses like 2,4-D when applied according to the label. Now, if you don't apply according to the label, you applied at too high of a rate or it's too hot outside, obviously you're going to have a problem with volatilization, but you actually can burn the turf too. So always pay attention to the label. We also have herbicides that don't hurt broadleaves. So if you have Bermuda grass sort of creeping into your vegetable garden or around your trees, for instance, maybe you can use fluazephat p-butyl or cethodim or clethodim or cethoxidin, pardon me. that will injure the grasses and not the broadleaves. Sorry about that. We also have herbicides that have dual selectivity. Now, just because they have the ability to control both grasses and broadleaves, the thing to understand about herbicides is they're always going to favor one category over the other. So with quinclorac, even though it is effective against grasses, it is predominantly a broadleaf specific herbicide. Does that make sense? However, it is probably the most utilized active ingredient against crabgrass, which is a summer annual grassy weed. Triclopyr is another one, predominantly going to be effective against broadleaf weeds, specifically going to injure trees and shrubs. Triclopyr is specific to woody plants, so you probably don't want to make an application of this around your tree roots because you can cause injury that way, right? I often get the question, how long does a herbicide last once I apply it? That's a really hard question to answer in a general sense. There's always things that depend, right? So you have some herbicides that have no residual control, like a lot of our contact herbicides, for instance, like paraquat, or our organic options. When you spray them, they don't really have the ability to last in the soil. And then you have something called residual control. Now there's two aspects of residual control to consider. How long the herbicide lasts in the soil, and how long it is active as a herbicide in the soil. Can everybody see the difference? A really good example of that, having short residual, would be glyphosate. Usually doesn't last more than about 20 or 30 days in the soil. But just because it can be detected in the soil doesn't mean it's going to be active as a herbicide to injure plants after the fact. I'll talk about that. Diaron, for instance, has a long residual in the soil. I've seen it active up to 3 years after the application was made in New Mexico. Usually it's only supposed to last about a year, so why so long? We'll talk about that. Now, why is glyphosate the one I mentioned as far as being different as far as how long it lasts in the soil and how long it's active as a herbicide? Glyphosate has a high KOC factor. That's a number that you can find on your material safety data sheet or your SDS sheet. The higher the KOC factor, the more likely it is to bind tightly to soil particles. When glyphosate comes into contact with soil, it binds so tightly that it does not move until the microbes eventually break it down. So just because it's present in the soil doesn't mean it's available to be taken up by the plant because it's so tightly attached to the soil. Everybody see that? So it's not likely that glyphosate is going to leach down into the underground root system of a tree because of that binding potential. Now, if the KOC factor is low, what does that mean for leaching potential? It can move, can't it? Read the label, the safety data sheet specifically, or the material safety data sheet. I don't know why they changed it. Soil half-life can give an indication of how long a product can remain active in the soil. If you're looking for sort of a guide, there are herbicides that are typically have very short active periods in the soil. Glyphosate being one, 2,4-D, fluazephat-p-butyl, sethoxidin. Anybody familiar with these? We apply a lot of those, especially these are our grass-specific herbicides. When you start increasing the likelihood that it's going to last in the soil, here we have dicamba. Now, even though dicamba and 2,4-D are two very similar herbicides that do almost the same thing in the plant, they have different properties to consider. And we'll talk about that. Halosulfuron, oxidazone, dimethenamide, benefin, metsulfuron. When you start getting into a little bit longer residual activity, here's when we start getting into a lot of our pre-emergent herbicide options, like pendimethalin, for instance, or dithiopyr, isoxaben, oryzolin. We also have some of these longer-lasting herbicides that I was talking about with lasting long enough to have active periods in organic matter. Clopyralid is one of those. And here, we have some of our longest-lasting herbicides, what are typically known as soil sterilants, although diaron certainly would fall into that category as well. Tebuthyron can last about 3 years in the soil, depending on conditions. So I say depends a lot when it comes to the residuals, how long these products last in the soil. Because it depends on the environment and whether the environment is conducive to breaking them down effectively, giving them time to break down. So what are some of the factors that help herbicides break down more quickly and effectively? Persistence of herbicide activity is dependent on soil moisture. Do we have that in our soils? Not so much. High temperatures? Bingo, we've got that. We've got a lot of sunlight, don't we? So they can photodegrade. A lot of our pre-emergent herbicides like pendimethalin, for instance, that's why you have to water it into the soil, otherwise the sun will break it down in about a week or two after the application. So is it going to last up to a month after that? No. What about humidity? Not so much. What about soil microbes in the soil to break down the herbicides as they consume them? Not so much. That's why some of our herbicides, like Diaron, for instance, which typically is considered to be only about a year long in our soils, I've seen injury up to 3 years. They just don't break down quick enough. We don't have the environment that's conducive to doing that. So like I said, that's difficult to determine. If you think you have active herbicide in your soil, do the same thing that I mentioned with the organic matter previously. Test your soil first before you put your desirable plant into it. When people think about tree roots, how to avoid tree roots with a herbicide application, most people think that you really only have to aim for the area outside of the drip line or the outer edge of the canopy. Do we know that to be correct? Right, this is a tree conference, right? Hopefully we know that tree roots are actually a lot more shallow than people think they are. You have the main primary roots that anchor the tree, but even those really aren't as deep as most people think they can be. For the most part, the most of your tree roots are going to be within about a foot or maybe even 3 feet deep underneath the soil profile. What does that mean for accidentally coming in contact with a herbicide? It's probably more effective than people think it is. So when you're talking about a good rule of thumb to avoid a tree root area with a herbicide application, it really is better to stay anywhere from 2 to 3 times the distance away from the tree root to the canopy. Did I say that right? Yes, okay. I never know in my head anymore. If you see an exposed tree root, don't spray over it. It doesn't matter if you're spraying a fertilizer, water, whatever's been in that tank previously, the best way to avoid any kind of injury to a tree is to not spray over an exposed tree root. Can't say that enough. So the last thing we're going to talk about is modes of action. How do these herbicides work in the plant, and what is the correlating injury that we might see? So say you are finding injury in your tree, you don't know if it's herbicide damage or not, what are some of the symptoms to look for? Well, the way that we can know that is know how these herbicides actually work inside the plant, their mode of action. Their mode of action, the function in the plant that the herbicide interferes with to cause that injury. And as I mentioned, that can be different with even active ingredients within the same mode of action. Using 2,4-D and dicamba as an example. They both have different methods of absorption. 2,4-D is foliar only, dicamba foliar and root absorbed. Different half-lives. Dicamba lasts a little bit longer, typically, not much, but a little bit. Different leaching volatility potentials and ability to injure off-target plants. Cotton, for instance, is very, very susceptible to dicamba. Pecans are very, very susceptible to 2,4-D, for instance. Doesn't mean the other won't cause injury, but that typically causes more. So how do these herbicides work in the plant? I've mentioned 2,4-D and dicamba a lot. What do they do to cause injury? 2,4-D and dicamba, their mode of action is that they are plant growth regulators. They inhibit plant growth regulating hormones from getting into our cells, or the plant cells, pardon me, not mine. So they mimic auxin. So as auxin is moving throughout the plant, the cell actually thinks that maybe that 2,4-D is actually an auxin cell, takes it in, and it doesn't grow as a result because it can't, because 2,4-D is not auxin. So you have some cells that are growing normally and some cells that are not. And that's where you get the injury that we'll see on the next slide. We have ALS inhibiting herbicides, meaning that they inhibit amino acid synthesis. Amino acids are energy for the cell. What happens if the cell doesn't get energy? It dies. Depending on what stage that could take a long time to do. We'll talk about that. This is the largest mode of action group. The active ingredients that are listed on the side of the bottle, about 60 to 75 of those all belong to this one mode of action group. What does that mean for resistance? There is a highest occurrence of resistance within this mode of action group over others because it's harder to switch those around if you don't know that they are indeed ALS herbicides. Now, there's also glyphosate, aromatic amino acid synthesis inhibitors. So I just talked about amino acids, didn't I, with the ALS herbicides. This is a very, very specific amino acid, which means that glyphosate is the only active ingredient that inhibits this particular amino acid production. It is its own mode of action. So if we develop resistance to glyphosate, what happens to that one mode of action? Gone forever. One of the 26, right? How do pre-emergent herbicides kill our germinating seedlings as they pass through that barrier? They prevent root growth. They prevent the root cells from elongating and replicating. So if you're coming out of a seed and you've used up all of the energy from the cotyledons and you can't grow your roots, what happens? You die. But that's also some of the injury that we see in our desirable plants that have been planted in an active pre-barrier. I have a picture of this. There's also photosynthetic inhibitors. Now there's different stages of this, there's different modes of action with this, but they all do the same thing. They in some way inhibit photosynthesis. What happens if a plant can't photosynthesize? It dies. In some cases, it dies pretty quickly, doesn't it? How does the mode of action help us in determining the injury that we might see in our trees? Whether one of our trees is showing injury or not, maybe your tree isn't looking good. Is herbicide the culprit? Well, let's see. Talking about the phenoxys, the plant growth regulating herbicides. Remember me talking about some cells growing normally and some cells that aren't? This is where you get that bending and that twisting and the cupping on the outer edge of the leaf from injury that we call epinasty. Usually this is the #1 herbicide injury symptom that we see. In many cases, if the herbicide is causing an interference with some major function in the plant, it's going to result in some sort of warped growth, right? So, this is a pecan tree on campus at New Mexico State University. If you start to see this sort of sea anemone-like growth in the early spring as they're trying to bud out, that may be an indication of herbicide damage, specifically phenoxy herbicide damage. It's trying to grow, but it can't. Now, does this tree look like it's pretty far gone and dead? It does. However, this is now 6 years after I took this picture. That plant is healthy and is producing pecans at this point in time. So just because it looks dead doesn't mean it necessarily is. And the reason that it didn't get any more herbicide damage is that we were actually able to talk to the applicators on campus, and they didn't make applications of the herbicide that caused this injury again, right? So this injury is pretty severe looking, isn't it? As opposed to, say, this injury here. It's just a little bit more surface area, if that makes sense. So which one of these looks like drift damage? Probably the ones in this picture, right? Causing sort of the surface level damage. Which ones do you think are root absorbed? Yeah, probably root absorbed, made an application in the fall, absorbed into the roots, and they tried to bud out in the spring, but the herbicide was already present in the plant. So this was an indication that the herbicide that caused this damage was dicamba and not 2,4-D. Can everybody see that? So here's another picture on campus of phenoxy herbicide damage, but localized specifically to one side of the tree. The thing with diseases, and in many cases insects, is that the injury is probably going to be more universal across the entire surface area of the tree. If you have injury that's localized to one side, it's most likely that something drift or caused that herbicide to drift into the side of that tree. Again, this is about 5 years after I've taken this photo. That's still growing out to this day. And it looks better every single year, but what do you think happened here? Somebody probably made a herbicide application to the gravel or the sidewalk that gets hot during the course of the day, and 2,4-D and dicamba being volatile, what happened? It evaporated right into that edge of the tree right there. Or I think it did. What about glyphosate? Stopping amino acids from feeding the cell. So what's the first injury symptom we're going to see? Wilt, right? It's not the latest dance move this year, I don't think, right? It's probably going to wilt. The leaves are going to turn yellow and chlorotic, and eventually it'll start to dry out as the cell continues to starve. Now, if you get superficial damage that's not actually going to kill the tree, but the plants or the leaves are trying to grow back, even though there's still some of that glyphosate present, you might get something that we call strapped leaves, which are longer, thinner, more elongated growth of the leaves. As you could probably see better in this picture here, also from campus. So as you can see underneath here, we have a lot of gravel, sidewalk area that gets hot, or that has a hard surface that when it's sprayed at a high rate, drift. Particulates happen, don't they? And more than likely, it drifted right into this lower branch. Now, as you can see, this injury is not seen in the top portions of the branch, which is why I think the drift occurred underneath the tree itself. Now, is that going to kill the tree? Probably not. Well, I actually didn't. I have the answer. It actually grew out of this injury within about a season or two. So even though it was superficial damage, but of course, when somebody sees this in their yard, they're not going to like that, are they? So those strapped, elongated leaves is another indication that maybe herbicide damage is occurring. Photosystem 2 damage. Remember that diuron active ingredient that I keep mentioning, the soil sterilant that I can see injury up to 3 years after application? The number one symptom to look at for photosystem 2 is the yellowing of the leaf veins. Now, can anybody think of what other nutrient symptom might get confused with this? Iron, right? Iron is intervanochlorosis, meaning that the inside of the leaf in between the veins is what's yellow, and the veins themselves are green. If you see leaf veins that are yellow and the inside of the leaf is still green, odds are you're dealing with a photosystem 2 inhibiting herbicide. Because there really isn't even a nutrient deficiency symptomology that mimics this. That's the number one symptom I see with this product in the plant diagnostic clinic. And the other thing to consider is that this symptom will usually appear in newer leaves. Why is that? They're photosynthesizing more, aren't they? This is inhibiting a very specific area of photosynthesis, and therefore the newer leaves are going to be the most affected. In contrast, with imazapyr or ALS herbicide damage, producing amino acids is the last stage of photosynthesis, and then those amino acids have to feed the cell, so it takes a little bit longer for those symptoms to actually start to appear. But the symptoms that we usually see are these basically stunted leaf stacking systems and that pipe cleaner symptomology that I talked about with salt cedar at the beginning of the presentation. So as you can see, there's something wrong with these leaves going on. Yeah, sure. I know I didn't talk about this, but I did want to mention this because anytime you see white in a leaf, it is herbicide damage. There is no nutrient, disease, or insect feeding that mimics white in a plant. So how does this herbicide work? It actually destroys the pigments in plant cells that protect chlorophyll. If chlorophyll can't be protected, ironically, what happens? The sun breaks it down. And therefore, the leaves turn white. And if the leaves turn white, they can't do what anymore? Photosynthesize. This is a very specific category of herbicide damage. Pre-emergent herbicides, remember them stopping root growth? Well, if you were to plant a desirable plant into an area that has active pre-emergent herbicide barrier in it, you might see something called clubbed roots. These swollen root ends right here. The roots of the desirable plant are trying to grow through, but it just can't because that pre-emergent is also inhibiting the desirable roots as well as the weeds as well. Now, usually this won't outright kill the plant, but if you compare swollen and clubbed roots to healthy roots in this corn plant, which one's going to die more quickly in stressed conditions? The one with the damaged roots, right? And do we have stressed conditions here in New Mexico? Of course, I'm stressed right now. Some important things to consider when we're talking about herbicide applications. Choose a herbicide based on the type of weed that you have, based on the identification, not necessarily the ease or the expenditure that's associated with that herbicide. Be more responsible with our applications. Be smarter and not work harder. Always take into consideration your surroundings when making these applications. We try to do that, right? But accidents happen. Always read and follow label directions. Can't stress that enough. Utilize methods and strategies to minimize off-target movement and damage as much as you possibly can. And become familiar with the herbicide modes of action and what injury that may cause. How do we know if we made a mistake or not? Well, the plants will tell us so, won't they? And if we know that we've made a mistake in that sense, then we can learn from that and hopefully we don't do that in the future, right? And more importantly, if your neighbor comes at you and says, I saw you spraying in your yard and this is what happened to my tree, you killed my tree. You can say, well, I have a copy of Dr. Beck's presentation, and I know that's not true. Let's take a look. Speaking of which, if you would like a copy of this presentation, feel free to shoot me an email. I'd be happy to send you a PDF. Moral of the story, get the weeds when they're young, before they have their gun license. And I'm from Texas, I can make that joke. If you need to get a hold of me, email is the preferred method, just like Dr. Lujan. But I'm happy to answer any questions you have now, or if you wake up at 3 a.m. and you have another question, maybe email me in the morning. Any questions? Everybody's like, get her off the stage. Thank you, guys. I'm happy to answer any questions y'all have after fact.
And we want to thank Leslie for coming out here and presenting with us today and with another tree cookie for you.
Delicious wood cookie. Thank you, guys.
Thank you. And do we have someone slated for closing comments? That wraps us up today, guys.
Oh, I was the last one.
Yeah, Leslie was the last one today. We look forward to seeing you tomorrow. Don't forget to buy raffle tickets. I feel like there's other things, but we'll figure it out tomorrow. Thank you all for coming. Thank you for staying to the end. Leslie's great, so I'm glad you stayed for her presentation.